Hello and welcome back to Historical Geology. I am Robert Lopez. Today we're doing chapter 3 on plate tectonics. Tectonics refers to building. It's really a movement and deformation of Earth's surface or Earth's crust, and that's where the tectonic plates are going to be. And when we look at the movement, it's really a force causing that movement, and that force is acting over an area. So force of over area is called stress. The rock is going to deform in a certain way, or it's going to react to that stress, and we call that strain. So strain is the deformation, and we'll mention those in a little bit here. So here's a picture of Alfred Wegener in 1912, who proposed this idea of continental drift, that somehow the continents were assembled together in this supercontinent that he called Pangaea, and he had quite a bit of evidence for that. In fact, he had 5 criteria. The first one is the coastline fit. Then he looked at rock records across ocean basins, especially in South America and Africa. You notice that the same rock sequence of strata in the same order occurred on either side of the ocean basin. There was strong glacial evidence. So glaciers, when they travel over bedrock, they leave striations, they leave these scratches on the bedrock. And during this time when Pangaea formed, at least that southern portion of Pangaea, the southern hemisphere continents, were over the South Pole, and an extensive glacier developed. And so the only way these striations make any sense is if you reassemble these southern hemisphere continents. He had quite a bit of fossil evidence, and he also looked at paleoclimate studies. For example, coal comes from plants, where plants are buried, and so we have lots of plants. Must have been a place where there'd been a humid environment. A good example is quite a bit of coal is found up in Scandinavia, in Sweden and Norway, but coal is forming in humid, warm environments, so obviously that coal formed in Sweden or Norway were closer to the equator. By the same token, corals only form in the tropics today, so we find corals up in northeast in New York State. Well, at some point in the past, that must have been near the tropics to form those corals. Where you find evaporite deposits like salt flats, well, that indicates it must have been an arid environment in the past, even though that area may be up in high latitudes or near the equator where it's wet. It still tells us that it's been in a different position. So that's where these paleoclimate studies fit in. So here's a picture of a continental drift and the coastline fit. Note that we look at the shapes of the coastlines, especially between South America and Africa. There's a good fit. Also between the west coast of North Africa and the east coast of North America here makes a good fit. And then for the rock records, here's a good example of the red here represents crystalline basement rock like granite or some sort of metamorphic rock. Then above the granite we have these glacial deposits, so that represents these glaciations. So note that on all South America, Africa, India, Australia, Antarctica, we see evidence of those glacial deposits across all these continents. And then we can match these lava flows across ocean basins as well, between Africa and South America, between Australia, India, Antarctica, Africa. So that's where this similar rock records across ocean basins fits in. The other thing I want to note here is most of this data that Wegener had was from the southern hemisphere. And those southern hemisphere continents include South America, Africa, India, Australia, and Antarctica. And so collectively, geologists call those southern hemisphere continents, they call it Gondwana land. Gondwana for short. It encompasses Australia, Africa, India, Antarctica, South America. Another thing about Gondwana, it had a long-lived history. It had lots of time to collect geologic evidence because it came together in the late Proterozoic, around 700 to 550 million years ago. So that was when it was amalgamating or forming this Gondwana land supercontinent. And the word we use is orogenesis. Oro means mountain in Greek. So orogenesis means the birth of mountains. So when continents crash into each other, they make high mountain ranges. A good example is a Himalaya range. India is crashing with Asia, and you're making the high Himalayas. Gondwana had a long history to collect geologic evidence. And then here's a diagram showing Gondwana land. And what I want to note here, where does North America fit into it? Well, Florida. Florida is really part of Gondwana. The glacial evidence. So if we reassemble Gondwana and we put Antarctica or really South Africa over the South Pole, we see that the glaciers are moving away from that central point, and they leave these scratches on the bedrock, and those are called the striations. So we can tell which way the glacier ice was moving based on these scratches. The other thing that glaciers leave, they leave a deposit. They move rock and they drop the rock, and that rock deposit is usually called tillite or till, T-I-L-L. Poorly sorted, kind of randomly haphazard, dropped off material. Here's more glacial striations, and then here's a drop stone. So if a big boulder was carried by the glacier, eventually it drops it off. Sometimes we call these glacial erratics. And in terms of fossils, one of the key ones is this Glossopteris flora. Glossopteris is a seed firm, and you can find it occurs on all these southern hemisphere continents. Even though today these continents are in widely different climate zones, here they're all in the same climate zone. Also, we have these mesosaurs, which are freshwater reptiles. They occur both in South America and Africa. They're not going to swim across the salty ocean, so there must have been a similar environment where these guys were living at the time. Also, Lastrosaurus over here was a reptile that also occurs in India, Africa, Antarctica, and it's showing a similar environment as well. And then Cygnognathus is a reptile-like mammal, or mammal-like reptile, and this one's also occurring in Africa and South America, just like the mesosaurs. And then for paleoclimate studies, like I mentioned, if you're at high latitudes, you're going to have glaciers. If you're at mid latitudes, you're going to have deserts, arid environments. If you're near the equator, you're going to have corals or salt flats, right? So here's reefs, salt deposits, right? So the fact that we have these dispersed all over the planet today indicates that these continents must have been in a different position in the past, hence the term continental drift.